Hello guys, welcome to our second video for algebra. Last video we looked at how to go from the written word to making those rules to turn them into expressions and equations. Now that's going to follow along into this lesson where we look at how to create and recognize the patterns of expressions and equations and put them either into words or another way to put them into expressions and equations. So we're seeing the actual use of these in real operations. Now, I am having difficulty with looking at getting my pen and my additional webcam working here, so we're going to try our best. But yeah, looking at this, starting off, we are seeing, I will take that, there we go. Erase all that, okay. So to start off, we are going to look at these tables. So these are called input-output tables, also sometimes called function tables. Now, input-output tables are sometimes called function tables or pattern tables because they help us find a pattern. The function or pattern is the rule. We are looking at the rule that is applied to all of these tables. The rule helps you understand the relationship between the two columns or rows. If you know the rule, you can complete any input-output table. So, for example, looking here, we have kids and the cans of soda. There is a relationship between the number of kids and the number of cans of soda. Sometimes you're given the rule and you have to fill in the rest of that chart, or sometimes you're given the complete chart and you have to find out what the rule is. You have to find out what that relationship is. For example, for the kids and cans of soda, the rule for this table is kids times 2 equals number of cans of soda. So you take this, X, let's say, or K, and you times it by 2 to get cans of soda. So it would be 2K equals S. And wherever you have the number of kids, you put that number in where K is. So 2 times 1, 2 cans of soda. You have 2 kids, it's 2 times 2. That gives you 4 cans of soda. 2 times 3 gives you 6 cans of soda, and 2 times 4 gives you 8. And you can go on for that forever. You can use the same rule to figure out the number of cans of soda needed for 10 kids. So rather than just seeing the pattern continue and create a table until you get to 10 kids, you can just insert that number into the rule. So 10 times 2 is equal to 20 kids, or 10 times 2 is equal to 20 cans of soda. And that can help you figure out a lot of things. In this case, how many cans of soda you need, but the rule can get more complicated, and it is definitely a time saver figuring out what the relationship is rather than just trying to fill out the rest of the chart. Let's look at the second one, X and Y. So we have 4 and 11, 8 and 15, 12 and 19, and 16 and 23. We can already tell it's not multiplying or dividing, but you can try and test what the relationship is. So how do you get from 4 to 11? Well, timesing it by 2 or 3 doesn't get you there, but adding 7 does. So if the rule works for one row, so 4 plus 7, you can see if it works on the next row, and it does. 8 plus 7 is 15, 12 plus 7 is 19, 16 plus 7 is 23. So you find out your rule. It can be a bit of a guess and check to see if that rule works. And sometimes a rule will work on one level, but not on another. For example, looking back at our one here, 1 plus 1 gives us 2. That seems like a good pattern. So number of kids plus 1 gives you the cans of soda. But if you try it here, 2 plus 1 is 3. Doesn't quite work, so you have to try something else. So the rule for this table, this X and Y, is X plus 7 equals Y. You can use the same rule to figure out future rows added to the chart. For example, if X is equal to 20, then Y equals 27. X plus 7 equals 27. Now, if you're getting larger, like these two examples, you're generally looking at adding or multiplying to get close to your answer. Now, if you're getting smaller, however, you're looking at subtraction or division. So for example, for this one here, you can test 25. How do you get from 25 to 5? Well, you're obviously getting smaller, so you can try subtracting. 25 minus 20 gives us 5. Seems like it could work. Let's try it here. 35 minus 20 doesn't give us 7. That would be 15. So we try something else. How do you get from 25 to 5? Well, you can divide. So 25 divided by 5 gives us 5. That works. 35 divided by 5 gives us 7 so far. You have to test it out with the rest of them though. 65 divided by 5, it does give us 13, and 80 divided by 5 gives us 16. The rule for this table is the input divided by 5 is the output. So this number divided by 5 gives us this number. You can use the rule and the inverse of the rule to figure out future rules for this chart. For example, if the output is 20, then the input is 100. You just have to reverse it. 20 times 5 equals 100. Ooh. Sometimes input and output tables have a two-part rule. Can you figure out what the rule is for this function table? You want to make sure it works for all of them. So when I say the two-part rule, and this is where I would like my camera to come into play here, so I will get this up. So our table is 4, 10, so in and out. We have 4, 10, 6, and 14, 9, and 20, and 13, and 28. There we go. Okay, so we will open up this. There we go. Okay, now this is going to be a longer video, so I appreciate your guys' patience. So sometimes, like it says, it can be a two-part rule. So one thing isn't going to fix just this. So we have to look what our input is here and see how it relates to our output. So to get from 4 to 10, we could just go plus 6. That seems to work. Awesome. 4 plus 6 equals 10. So input, so let's just go I plus 6 equals output. Well, let's call this x and y because we never want to use O because it can be sometimes confused with 0. So x plus 6 equals y. That doesn't work here though. 6 plus 6 is equal to 12. Doesn't work there. So you might think, all right, it's multiplication. But you can't multiply 4 evenly to get to 10. You can with decimals, but we aren't going to do decimals at this stage. We're just going to stick to whole number integers, positive numbers. Positive whole numbers. So we have a two-step solution here. So what normally happens is if you have two steps, you multiply or divide to try and get as close as you can to the output number. And then you add or subtract to get your additional number to get to the final stage. So a number that we could try here is 4 times, let's say 3. So 3 times x, so 3 times the input would give us 4, 8, 12. So it would be 12, and then to try and get to 10, we would have to subtract 2. That might give us it. So let's try it. So 3 times 4 is 12, minus 2 is 10. Works for that one. 3 times 6 is 18, minus 2 is 16. So this rule doesn't work. Let's try it the other way. Let's go under it a little bit. So 4 times 2 is 8. So let's go 2x. To get from 8, because now we have 2 times 4 is 8. To get from 8 to 10, we have to add 2. Plus 2 gives us y. So let's see if that works. 2 times 6 is 12, plus 2 is 14. That seems to work. That works for that one. Let's try it the others. 2 times 9 is 18, plus 2 gives us 20. Looking good so far. 2 times 13 is 26, plus 2 gives us 28. So this is our rule. It is a two-parter. 2x plus 2 equals y. Now, when I said that this video is going to be a little bit longer, it's because I am going to go through the second worksheet with you. So what we have is this here. I will get off of this. So this is our intro to the tables and values again. Now, we are creating and using rules with the table of values. Now, like I said at the beginning, one of the two ways that we can do this is we are given an incomplete table and we fill in the rest, or we are given a complete table and we have to figure out the rule. So let's just start with the incomplete table first when the rule is given. That can help us just firing in those numbers and completing the charts. I'm going to switch back and forth between the two here, okay? So starting off, again, a table of values is a T-chart that shows a relationship between an input, x, and an output, y. We can use rules to complete a table of values, or we can use a table of values to create a rule. So let's start easy though, using a rule to complete a table of values. When we're given a rule for a table of values, we can use that rule to complete the table. Just substitute the values you know into the rule and then solve to find the unknown. Now remember to use the order of operations. So starting off, our rule here is x plus 5 equals y. So I'm going to switch to this camera here. So our input is 4, 5, 6, and 10. And our rule is x plus 5 equals y. So when we are looking at completing this row, oops, sorry, there we go. Wherever the input is x, and the output is y. So the input is 4 plus 5 is y. So 4 plus 5 is 9. That's our output. 5 plus 5 is 10. 6 plus 5 is 11. And 10 plus 5 is 15. It is simply substituting those in. Okay? And I'll be sure to put in the complete key for you guys to reference as well for this new online learning. Let's try another rule. The next one is 4x plus equals y. So remember, when we have 4x, when the coefficient is right next to the variable, that means the coefficient is the variable is multiplied by that number. So we are multiplying 4 by whatever the input is to get our output. So we have 1, 2, 3, and 25. So 4 times 1 is 4, because our input is 1, and that's what the x becomes. So 4 times 1 equals 4. 2 times 4 is equal to 8. 3 times 4 is equal to 12. And 4 times 25 gives us 100. Now again, you guys can pause just before these if you want to try figuring it out on your own, and then watch the video right after, or look at the key right after, and it might help you out. Okay, next one. We have going the other way. It can go the other way as well. Y divided by 2 is equal to x. So we're given the output instead. So we are given 50, 32, 14, and 2. So now we have to take the y, divide it by 2, so this number divided by 2, and that gives us x. So to solve that, we simply go 50 divided by 2 is 25. 32 divided by 2, 16. 14 divided by 2 is 7. And 2 divided by 2 is 1. Now, for a double step one. This is part of those two steps. So input is x, output is y. Our rule is 3x minus 1 is equal to y. And our inputs are 3, 4, 5, and 100. Now remember, we're going order of operations here, that bed mass. So we have to do the multiplication first, and then the subtraction. Remember, all we're doing is putting in this input number where the x is. So it is 3 times 3 minus 1. 3 times 3 gives us 9, minus 1 is 8. 3 times 4 gives us 12, minus 1, 11. 3 times 5 is 15, minus 1, 14. 100 times 3 is 300, minus 1 gives us 299. And that is it for those. We do have one more example because it is another two-step, and I do want to give it to you guys. And so let's just do that one quick. So another two-stepper with a division instead. We have x divided by 2 minus 3 is equal to y. We have 8, 10, 12, and 100. Now again, you simply put them in, follow proper order of operations, that bed mass, and then follow through. So where the x is 8. 8 divided by 2 is 4, minus 3 is 1. 10 divided by 2 is 5, minus 3 is 2. 12 divided by 2 is 6, minus 3 is 3. 100 divided by 2 is 50, minus 3 is 47. So there's our completed chart. Now, going back to, and this is the last bit, and I will try and make this a little bit quicker, just so I know you guys can rewatch the video, but I am also on a Chromebook, so I can't save as much data for compressing this, and I'm wasting time talking about it. I just have to make sure the video doesn't go too long. for the computer and for yourself. Okay, so we've looked at putting in what we're an entire table that we're given when we're given the rule. But what happens if we're trying to find the rule? So we can look at a completed table of values and determine what the rule is. We need to look for a pattern or relationship that works for each of the row of the chart. After finding the relationship, we have to create a rule. So think, what did I have to do each of the input numbers to get their corresponding output number? So let's look at some examples. I'll bring this up again. So let's look. We have X and Y, our input and our output. For the first one, let me just get my sheet here. For the first one, we're given the input of 1, 2, 3, and 100. And our output is 4, 5, 6, and 103. So again, you always want to try just doing addition or subtraction first. If the number is getting bigger, you're obviously going to do addition. If the number is getting smaller, you're obviously going to do subtraction. So how do you get from 1 to 4? Well, you simply add 3. So the rule would be our input plus 3 equals our output. That works. 2 plus 3 equals 5. 3 plus 3 equals 6. 100 plus 3 equals 103. So what did you do to the input? You went X plus 3 gives us Y. And that is our rule. That's it. Let's try another one. We have our input. We have 1, 4, 5. Oh, no. 100. We have 50. Now, our output is 2, 8, 10, and 100. So again, we see that the number is getting bigger, so try adding first. 1 plus 1 equals 2. Good. 4 plus 1 equals, it doesn't equal 8, so we know we have to maybe try multiplying. So let's try multiplying next. How do we get from 1 to 2 multiplying? Well, we just multiply it by 2. 1 times 2 gives us 2. Good. 4 times 2 gives us 8. Yep. 5 times 2 gives us 10, and 50 times 2 gives us 100. So we have our rule. X times 2 equals Y. But again, we can't do it like this because we don't know if this multiplication sign is a variable or an operation. So we have to erase it. And remember, our proper way to do it is to make it a coefficient, a number in front of that variable. So now this says 2 times the input, so 2 times X gives us Y, the output. And believe me, I will be happy to explain this one-on-one as well. This is just an overarching lesson. Let's look at the next one. We have 42, 40, 20, and 100. We have 21, 20, 10, and 50. So the number's getting smaller. So let's try subtracting first. How do we get from 42 to 21? We subtract 21. So 42 minus 21 gives us 21. 40 minus 21 doesn't give us 20. So we know it's not subtraction. Let's try division. How do we get from 42 to 21? We divide it by 2. 42 divided by 2 gives us 21. Excellent. 40 divided by 2 gives us 20. 20 divided by 2 gives us 10. And 100 divided by 2 gives us 50. So our rule is X divided by 2 equals Y. So you can write it like that or write it like that. You guys can see me without my face there. There you go. So both of these are the rule. The number, the input, X, divided by 2 gives us the output, Y. And then finally, looking to create a rule for something that is a two-stepper. Okay, that it takes 2 steps. So we have 1, 2, 3, 100. And we have 3, 5, 7, 201. So we see that the number is getting bigger, so we simply try adding first. To get from 1 to 3, we go plus 2. Okay, 2 plus 2 equals 5. No, it doesn't work. So we look at multiplication. To get from 1 to 3, we times it by 3. So we go 1 times 3 equals 3. Good. 2 times 3 equals 6. It's not lining up. So we know it's going to be a two-step equation. So let's try going over first. 1 times 4 gives us 4. To get to 3, we have to subtract 1. So 4x minus 1. gives us this. Perfect. 2 times 4 is 8, minus 1 gives us 7. Doesn't work there. So let's try under. To get close to that, we would go 1 times 2 gives us 2. And to get to 3, we would add 1. So our equation is 2x plus 1. Now we check to see if it works on this one. 2 times 2 equals, right? 2 times 2 equals 4 plus 1 gives us 5. Well, that works. 2 times 3 equals 6 plus 1 gives us 7. So far, so good. Now the big one. 2 times 100 gives us 200 plus 1 equals 201. So this is our final rule. 2 times the variable, the input, plus 1 is equal to y, the output. And that is it, guys. I know that seems like a lot. It was a lot of explanation, I understand that. But we are going to be going through it slowly and working our way with it and doing a lot of practice. So I don't want you guys to stress too much about it, okay? It is a skill that we will be learning, and I'm excited to do it with you guys. Okay, thank you very much, and we will talk to you soon. Bye.